Okay, it's time for me to do the chemistry prep. Isn't this exciting? So, first of all, I need to tell you about the groups. Now, the groups are quite simple. Each column is another group. Group 1, 2, 3, 4, 5, 6, 7, and 0, or 8, depending on how you like to think of things. Period is also simple. 1, 2, 3, 4, and so on until you reach 7. Now, the group you are in depends on how many electrons are in the outer shell of the element. This has 1 electron in its outer element, 2 electrons in its outer shell, and so on. The period is how many shells you have. So, 1 shell, 2 shells, and so on. Relatively simple, if I say so myself. Now, as for the metals and non-metals, these are quite simple actually. Boron is a non-metal, this is a non-metal, this is a non-metal, 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 and everything to the right of the elements that I pointed out are also non-metals, while everything to the left is a metal. If you want some more clarification, let me repeat that again. Non-metal, 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 and non-metal. And once again, everything to the right of those I said are non-metals, while everything to the left are metals. What else do we need to learn about in this exciting prep of ours? So, an explanation of what the atomic number is. As you should be able to see there, that is the atomic number on the bottom of the element. Now, the atomic number is how many electrons this atom has. So, as you can see, lithium has 3 electrons, beryllium has 4 electrons, sodium has 11 electrons, scandium has 21 electrons. And then I need to tell you about the atomic mass. Now, this is also simple. It is the number on the top, and it is the electrons and the neutrons added together. As you can see with lithium, it has 3 electrons and 4 neutrons, making 7 the atomic mass. All very simple. It is the same throughout, no matter which element you look at. Now, here's an explanation about something to do with the groups that makes them all similar. All groups react in similar ways to the same substances. For example, group 0 or 8, they are all fairly non-reactive. This is because their outer electrons are full. Therefore, they do not need to gain any electrons to fill their outer shell. Please note, however, that obviously atoms aren't sentient, otherwise we would all be crazy. Yeah. Now, since we're not all crazy, atoms do not actually have minds. Therefore, this is just an expression or personification if you're good at English. Now, in group 1 and group 7, these are all fairly reactive. Now, group 1, its reactivity goes down like this. At the top, lithium is the least reactive, all the way to the bottom with francium, which is the most reactive. Now, there is a very simple reason for why it changes in reactivity. It changes because as the electrons get further away from the atom, or which you can tell by their period, the attraction connecting them to the nucleus begins to fade away. Therefore, they're more willing to fly off to join the other elements. In group 7, however, it is actually the opposite, starting off with the most reactive to the least reactive. This is because, once again, as the electrons get further away from the atom, they lose their attraction to the nucleus. However, for this atom to become whole, it needs to have a full outer layer. Therefore, when these electrons fly away, it's very bad for it. In other words, here it's very close to becoming whole and therefore very reactive. Now, I think I've explained just about everything. Thank you for the prep.